This is a water outlet from my VS 800 Suzuki intruder. It got a crack in the side of it, so it's leaking. And I tried to repair it, but I got a little bit hot. But anyway, I thought I'd design one myself and make a new one out of 6082. I noticed that the inlet in the bottom was a lot smaller than the outlet, so I thought I'd redesign it so we could get a better water flow out through the end of it. Because as you can see in the new one, it's a lot wider space coming out through the outlet. So anyway, I drew it up on my CAD and started to machine one on my CNC machine. Bit of a challenge, I thought. I used a 6040 EST CNC, one of these Chinese machines. Done a bit of a modification to it to allow it to be able to machine aluminium. As you can see, it's machining pretty well. Feed rate's about 600 millimeters a minute. Spindle speed's around about 10,000 RPM. And the cut depth is, well, the rough cut depth that I'm doing here is 0.5 mil with a 2 mil step over. Most of it's been cut dry. Occasionally I'm giving it a squirt with some WD-40, and there's also an air jet set up that occasionally blows the dust out. And as you can see here, it's cut out the inner cavity and it's done a nice job of it. It's come out nice and clean, pretty smooth. The finish was a 0.2mm step over, hence why there's some small ridges on the inside. But it was good enough for what I wanted. And now we're using a 6mm bit once again. I think I slowed the speed down here to about 400 millimeters a minute. I wanted to get a nice smooth finish on the base, as this is where the seal will be put to clamp this part down to the actual engine. So I wanted to get a nice smooth finish on this part. As you can see, it's come out nice and smooth. Not a lot of vibration on the cuts there, as you can see. Yeah, it's done a really nice job. So the next step here is using a 3mm bit. I think it's running at 600 RPM. Feed rate's only about 300-400 millimeters a minute once again. I wanted to get a nice smooth finish around the edge, as this is just cutting out the outer edge of the object within the block. I actually started off with a 200 by 80mm by 38mm deep block of aluminium. And as you can see, it's doing a pretty good job. It's cutting out the little seal section. This is where the rubber seal will sit. It's 3mm wide, 1.5mm deep. And that's what I make the seal between the water outlet union and the actual engine itself. I didn't actually expect it to cut as well as it has been. Yeah, it's pretty impressive. The controller I'm using is the DDCS V3, which is running the G code. The stepper motors I used are NEMA 23s, and they're closed loop, which seem to work very well on this setup. But yeah, Very happy with the way it seems to be cutting. So when you think about what you can cut on your machine, you could pretty much do anything you like on these hobby machines. You just got to get the feed rates and the speeds right. It's not all about doing it as fast as you can. And obviously if you turn the feeds down, you'll get a nice smooth finish. I mean, I could probably push this a lot harder than what it is. I mean, as it is a pretty rigid machine since I've upgraded it. But I was in no rush to finish the part. As you can see here, it's a nice smooth finish. Right, so that's the first side finished. So next step now is to flip it over and machine pretty much the rest of the material away, so we can have a finished part. These are about the same as before, using a 6mm. This is a three flute bit. Doing the same again, cutting at 0.5mm in depth, 2mm step over, running about 10,000 RPM. And the feed speed again is still only about 600 or 700 millimeters a minute. Yeah, I could run it faster, but no rush. And I didn't want to take a chance of the block actually dislodging out of its position. Ah, we're actually on the home stages now. This is doing the finish cut. Still using the same end mill, 6mm end mill, 3 flute. I didn't see any need to change it to a bore mill. I mean, it gives a nice finish as it is. The step over's 0.01, I think. I think I've done it a little bit too low. It took quite a bit of time for it to run across. Feed rate here is running at about 1200 millimeters a minute. And the spindle speed the same as before, 10,000 RPM. It seemed to give her quite a nice finish. And the top end here, where the hose sits, I cut bigger. That'll allow me to machine it down. This was a new idea. I thought I'd 3D print out a mount to mount it on, so I could cut the centre out and machine the outer edge. I was wondering whether it would work or not, so I turned it right down. I'm using a 3mm bit here. I slowly increased the feed rate until it started to get a little bit of vibration. I think it ended up being around about 500-600 millimeters a minute at speed. Depth I'm cutting is only about 0.25 millimeters. It's only taking a very small cut. but I found I had to stop it about every 5-10 minutes to allow the part to cool down. I didn't want the plastic clamp to melt, but eventually it cut it out and it done a pretty good job. Here I'm now cutting the outer circle, bringing it down to size, the 25mm. Here I'm using a 3 flute 6mm bit. It's running at about 1000mm a minute. It's only cutting down 0.25mm once again. Mainly because I didn't want to cause too much vibration as it's only a plastic mount, and that seems to hold really well up until the point where I decided to do a finish around the outer edge, and as you can see, it when it got to the front of it, it got quite a bit of vibration. But considering, I'm pretty pleased with the outcome. So it is possible to 3D print out jigs to mount on your CNC. Well, I hope you enjoyed the video. It was a bit of a challenge for me to make this part. It's come out alright, so the next step now is to fit it on the bike. Thanks for watching.